One of the ideas is this concept of memory consolidation really requires the hippocampus, the way we talk about it at least. Memories come into the brain. In the short term, they're in the hippocampus. And then with a bout of sleep, those memories are replayed and then shuffled out to the cortex. And that's a model, though, that requires a developed hippocampus. And some developmentalists would say the hippocampus isn't really sufficiently developed until 18 to 24 months. And so there's a prediction that memory consolidation would be different before that age. And that's kind of a confusing prediction because there is sleep-dependent memory consolidation before 18 months, but it's not using the hippocampus to do so. And that idea relies more on synaptic downscaling. So it's possible that you could still have a sleep benefit before 18 months, but that's just coming about from brain-wide synaptic downscaling with sleep versus after that 18 to 24 month window is when you have the systems consolidation that we more commonly talk about. So we're doing longitudinal studies in our lab now to where we can really follow a kid from 16 months to 31 months to see if we see any evidence of a change in what memory consolidation looks like before 18 months to after 24 months. There's huge variability in the development of the hippocampus and of memory, and it's in this 3 to 5 age range, which is right around when, at least in theory, have come out of infantile amnesia around that window. But I believe that hippocampal amnesia reflects a certain amount of filtering of memories, right? I mean, it's got to be saying this little kid has done all of these different experiences, but somehow you're able to remember how to write letters, which you learn in that age range, but you don't remember your third birthday party, which also occurred in that age range. And so there's probably a good amount of information that's getting sorted in terms of what is going to get stabilized and held long term and what is maybe that's nice in the short term. And I'm going to pull out kind of maybe generalities that you learned at that birthday party. Maybe you learned what balloons are, you learned what cakes are, something. You put that onto kind of broader concepts. And so I think there's some filtering going on of those early memories. And we know sleep is really good at that. So we know we can stabilize the veridical memories during slow wave sleep, but we also seem to think that it looks like REM sleep is a good filter. So we can say, save everything. Here's what to keep working on when you keep going back into slow wave sleep. So I do think that sleep potentially plays a role here in contributing to maybe the production of synapses related to some aspects of the memory, but also the reduction of synapses during REM for maybe the areas that aren't worth saving.